Hey guys, I'm going through today's in-class assignment, so hopefully we'll get through all of these problems. Starting in 10.3 with number 36, which says that 1 over x squared plus 9 over x plus 8 is equal to 0. I'm going to write off to the side that x may not equal 0. And let's multiply everything by x squared. When I do that, I'll just end up with a 1 here, plus a 9x, and plus 8x squared equals 0. I'm always a little bit more comfortable solving these things if they're written in the opposite order here. Plus 1 equals 0. And let's hope that this thing is factorable. I'm feeling like an 8x and an x will probably do the trick. How about a plus 1 and a plus 1 equals 0? Just to make sure, 8x times x, 8x squared. I've got an 8x and another x. There's my 9x, and 1 force multiply together to get 1. So x should either equal negative 1/8 or negative 1. Plugging both of those things in, that looks to be about right. Let's call that good. Number 37 is our next one. Find the zeros of each function. And my function is f of x equals x squared minus 49. Ooh, I feel like squares coming on. Over x times x squared plus x over x plus 7. All right, right off the bat, I realize that x may not equal either 0 or negative 7. And let's factor these things. I've got an x minus 7, x plus 7 times an x times x plus 1 all over an x times x plus 7. And the x plus 7s go away, one on the top, one on the bottom. The x's go away. And I'm left with a function which is just a quadratic, x minus 7 times x plus 1. So my zeros are x equals 7 and x equals negative 1. Good to go. Next up is 41, which is addition. It really seems weird that addition is harder than multiplication when we get into fractions. X cubed minus 27 on the bottom, that's going to be a difference of cubes, plus 9 over, and they have 27 minus x cubed. It's also a difference of cubes, but more to the point, it's the opposite of that. So I think we can write this as x squared minus 9. I changed the adding to a minus because I switched the order here to become an x cubed minus 27. We will continue to simplify by factoring the numerator, which was a difference of squares. Oops, that should be a minus 3. And the denominator, which is a sum of squares. Remembering that mantra with the same sign, x squared, with a different sign, 3x, and always end with a plus 9. This guy and that guy go away with x not being allowed to equal positive 3, and I'm left with x plus 3 over x squared plus 3x plus 9. This, including that restriction, is the answer. You can also say that x squared may not equal, or that x squared minus 3x plus 9 may not equal 0, but we still see that. Okay, so there is number 41. Don't want to lose this. That's much problems to do. So we're on to 45. In number 45, add or subtract and simplify. And in number 45, it starts by looking like x cubed minus x squared over x plus 2 minus 4x minus 4, also over that x plus 2. Okay. They have a common denominator, so if you just go ahead and do this, minus x squared minus 4x. But remember, it's going to be a plus 4, because what are we really subtracting? We're subtracting that over an x plus 2 situation. Right. So now we have to see whether this thing is factorable, and more to the point, whether an x plus 2 can come out of it. It's a 4 of them, so my first line of defense is factoring by grouping. I pull an x squared out of my first two terms, I'm left with an x minus 1. And if I pull a negative 4 out of my next two terms, I'm also left with an x minus 1. What a wild coincidence. All over x plus 2. That makes this x squared minus 4 times x minus 1 all over that x plus 2. That is, of course, factorable with the difference of squares as x plus 2. Ooh, who would have guessed? X minus 2. Still have that x minus 1 and this x plus 2. Those guys will cancel out with the caveat that x may not equal negative 2. So my answer, and I'm going to leave it in factored form, which is fine, is exactly this. I do need that restriction in there. That's number 45. The last one from this group is number 49, where we're solving an inequality. So the original problem reads x squared plus 2x plus 1 over x squared minus 1. I mean, that feels like a difference of squares to me, is greater than 0. Okay, as is the case so often with these inequalities, what I'm first going to do is find the boundaries by setting this thing equal to 0. And this is a perfect square on top. It looks like x plus 1 quantity squared over x plus 1, x minus 1, and where that equals 0. Well, on my number line, I first see where this equals 0 at negative 1. It's also an interesting point because these things cancel out. And so that is a hole in the domain, and that's an interesting point to plug in regardless, as is this one. And clearly when x is either of these two things, this function fails to exist. So those won't be members. I'm going to reduce a little bit here by canceling that guy and that guy. And we're going to see where this thing is greater than 0. So if I plug in a largely negative number, like negative infinity, then this is a positive number over pretty much the same positive number, because I can ignore those things. And I would have something really close to 1, which of course is greater than 0. So yes, between negative 1 and 1 is 0. I'm just going to cover up anything which has an x in it. I have a positive 1 over a minus 1. That is negative 1, of course, not greater than 0. And the same exact thing happens when I plug in a really, really large number, so large that I can ignore those other terms. I've got x squared over x squared, which is essentially 1. And so, yes, it works there. The answer in interval notation would be everything from negative infinity, of course, never including negative infinity, up to negative 1, and we can't include negative 1, and everything from positive 1 up into infinity. Okie dokie. The next set of problems are in section 10.4, and I'm doing everything from 59 to 61. 10.4, everything from 59, which has a solve. Okay. So problem number 59, it's something like this, where I say 1 over x plus 1 over x plus 1 is equal to 2x plus 1 over x times x plus 1. So the first thing that I want to do here is I want to find a common denominator. To make this denominator in quotes happy, it needs to have an x. To make that one happy, it needs to have an x plus 1. And to make this one happy, it needs one of both. So if everyone has one of both, then everyone should be in quotes happy. I'm going to multiply this first term by x plus 1 over x plus 1. I'll get x plus 1 over my new common denominator, x times x plus 1. I'll multiply this term by x over x. I'll end up with an x over, of course, that same denominator. And this one I can just leave alone over x times x plus 1. My next step, I'm going to eliminate those denominators. Technically, I'm multiplying everything by x over x plus 1, but I should remind myself that x may not equal 0 or a negative 1. So I've got x plus 1 plus another x equals 2x plus 1. Noodle scratcher here. It seems to me that 2x plus 1 equals 2x plus 1. So it works for all numbers as long as x is not equal to 0 or negative 1. For the fun of it, let's just plug in a number which isn't 0 or negative 1. 1 is always nice and easy. And I would get 1 over 1, which is 1, plus 1 over 1 plus 1, so plus 1/2 equals, and here I would get 3 over 1 times 2, 2. 1 plus 1/2 does equal 3/2. I like it. So this really is my answer. X does not equal 0 or 1, but again, written in interval notation, everything from negative infinity on up to negative 1, and everything from negative 1 to 0, and everything from 0 to infinity. Cool. Let's look at 60. Number 60 says it takes machine A twice as long to produce 10,000 bolts as it takes machine B. Together, they do the job in 8 hours. How long will it take each machine to produce 5,000 bolts if each works separately? Okay, so for problems like this, I use distance equals rate times time. And this is a together, I suppose. Yep. Then A alone is going to be distance equals rate times time, and B alone is going to be distance equals rate times time. I underlined one of them, I might as well underline all of them. Now, in this case, it isn't the same distances. I could use 10,000 volts as a distance. That's really how much job of this to do. But that's making things a little bit overly complicated. 10,000 isn't a particularly fun number to work with. Together, they're really just doing 2 times what they were doing individually. This would be rate of A plus rate of B times 8 hours, I believe they told me. 1 equals the rate of A and the time of A. It takes machine A twice as long. So I'm going to say, instead of time of A, I'm going to say 2 times the time of B. And over here, this would be rate of B times the time of b. Hope that all makes some degree of sense. I'm going to say that 1/4 equals the rate of A plus the rate of B. Speaking of the rate of A, I'm going to say that it is 1/2 times the time of B equals that rate of A. And over here, I'm going to say that it is 1/, the time of B, which is that rate of B. I'm going to substitute both my rate of A and my rate of B back in over here. Get that 1/4 equals rate of A, which I suppose I meant to call, let's just cross that out. 1/4 equals 1/2 times the time of B plus 1/, the time of B equals, no equal sign there. Okay. I can find a common denominator here. I can multiply this guy by 2/2. You can technically have multiplied this guy by 1/2 over 1/2, but tomato, tomato. So 1/4 equals 1 plus 2 over 2 times the time of b. I have a small objection to the phrase cross multiply, just because people tend to think of it as a completely different operation than just multiplying both sides by this denominator and both sides by that denominator. But when I do it, I get 2 times the time of b equals 4 times 3 equals 12. And it seems like the time of b should be 6 hours. Since the time of A is twice that, the time of A should equal 12 hours. And I should put units here. And I should probably put a little half a sentence to say it takes machine A 12 hours and machine B 6 hours. You are welcome, of course, to do that. All right, the last one from this section is number 61. 61 says the expression this thing can be simplified to that thing. Find the binomial p of x. I should probably show this. Right. So the expression this thing can be simplified to that thing. Find the binomial b of x, and the result has the obvious restriction that x may not equal 2. Why must we also restrict the answer to x may not equal 5? Well, really right there. And for that matter there, that if x were -5 in the original equation, we would end up dividing by 0. So really all I'm going to do here is 61a, which is simplifying x over x plus 5 plus 2 over x plus 2 minus 15 over the product of both of those denominators. Okay. So that is where I am starting. In order to make all the denominators happy, they're going to end up looking like this. So I'm going to multiply x by x plus 2. And of course, its denominator by x plus 2 as well. This one, I am multiplying the top and the bottom by x plus 5. And there's the x plus 5 in the bottom. And x plus 2 goes right there. This one was already containing everything. I don't need to change it at all. Hi, bug.
I'm not bug.
Oh, hi, princess. So sorry.
Hi, what's your name?
I am Daddy.
They right here.
Minus 10 because we are distributing that. And minus 15. over x plus 2.
Let me check you high.
You're going to check my height?
Yeah.
So we got x squared minus 25. Seen a lot of different squares today.
Look up.
Honey, can you let Daddy finish this, please?
A princess.
Oh, I'm sorry. Princess, can you let Daddy finish this, please?
Well, you need to check you high.
Okay, I will pause this in just 1 second, and you can check my height. All right. It looks like the polynomial in question b of x is simply equal to x minus 5. Yes, you can have that calculated.
So turn it on.
Yes, I will turn on the calculator on. There you go. Enjoy. All right, go see Mama.
No, I need to check your high.
I'm gonna pause this for a minute. Okay, I am back. So b of x equals x minus 5. We also answered part b of that problem. We must restrict x not to equal -5 because we kind of canceled it out over here and it can no longer be seen. But in the original equation, if x were to equal -5, bad things would have occurred. The rest of the assignment is from 10.5. We're going to start with problem number 16. Right. Problem number 16 says, find the ratio of the area of the triangle to its hypotenuse. Okay, and I am drawing this triangle backwards of what they drew, just seems to fit a little bit better. There is a 4x. There is a 3x. What are the restrictions on x? X has to be greater than 0. Clearly, you cannot have a triangle where one of the sides is negative or even 0. Okay, so restrictions find the ratio of the area of the triangle. So the area is 1/2 base times height as a general rule. That'd be 1/2 of 3x times 4x. Not that one of them has to be the base and one of them has to be the height. 1/2 of 4x is 2x times 3x should equal 6x squared. The hypotenuse, I'm going to refer to my good friend Pythagoras, who told me that a squared plus b squared equals c squared. So I'm taking one of my sides, which is 3x, and I am squaring it. I'm taking my other side, which I wrote as b, which is silly, change that to a 4x, and I am squaring that equals that hypotenuse squared. This would be 9x squared plus 16x squared equals c squared. This luckily is 25x squared equals c squared. That's lucky because I can take the square root and I find that c is equal to 5x. So when I look for the ratio of the area over here to the hypotenuse over there, I have 6x squared over 5x, which reduces to 6x over 5. And there it is, along with my restriction that x has to be greater than 0. Next up is problem number 19. That's off to the recycle bin. Simplify or solve. Number 19 stated that 2x minus 3 over 4x minus 2x minus 1 over 2x. I guess we can't solve. There's no equal sign. Let's multiply this side of the equation by 2/2. I get 2x minus 3, and the whole thing is over 4x now, minus 4x, and don't forget to distribute that negative, plus 2. This thing is going to read negative 2x. And it looks like minus 1 all over 4x. I feel like that is as good as it gets for that one. Number 20. It's the same group, so it's still simplify or solve. This time we have an equal sign, so I will be solving. It is the exact same thing. Dot, dot, dot. It's just that this one equals 0. I'm going to say negative 2x minus 1 over 4x. We'll set it to the exact same setup, equals 0. This happens only when the top is equal to 0. So technically I'm multiplying both sides by 4x and saying that x may not equal 0. So I get negative 2x minus 1 equals 0. Negative 2x equals 1. X equals negative 1/2. And that is my answer. It should not include the restrictions because if x is equal to negative 1/2, then x isn't equal to 0 anyway. Looking through these, 2 more. Number 29 is next. Solve for x and graph the solution on a number line. Number 29 starts by saying x squared minus 9 over x squared minus 6x is greater than or equal to 0. All right, factor in the top and the bottom, x plus 3, x minus 3 over x times x minus 6. I'm going to say equals 0 and put all my critical points over here. We do have 0. Funky things can happen at 0. We do have a 6 out here. We do have a positive 3, and for that matter, a negative 3. So all kinds of different possibilities. If I pick a number, a generic number less than, sorry, that was a little off screen, less than negative 3, and I plug it in here, and this will be negative, that will be negative, that will be negative, and that will be negative. 4 negatives make a positive, and a positive is greater than or equal to 0. I'm going to fill in these dots here, literally filling in that one and making this one an unfilled one and unfilled one. If x equals 0 or 6, then the function is undefined. If equals negative 3 or 3, then the numerator is 0, so the whole function is 0. If I look at the region between negative 3 and 0, no, honey, I'm not going to take that off right now. Then most of these stay exactly the same. The only one which changes is that one is now going to be positive. Right? So if I have something like negative 2, for example, this would be a positive number. Now I have 3 negatives and a positive. That is not a positive number or 0. Likewise, when I jump into this region, the only number which changes is that one. Now I have 2 negatives, which make a positive, times a number of positives, which remain positive. Again, one number is going to change. This one is going to change in this region, and one more number will change in that one. So we have this alternating pattern where it works from negative infinity up to and including negative 3, never includes infinity. It works from 0, but not including 0, up into positive 3, and it works from 6, not including 6, up to infinity. All right, that's kind of fun. Last one here is problem number 42. After a rainstorm, ooh, looks like another one of those work problems to me. Here it is. After a rainstorm, pipeline A fills a reservoir in 2 hours. Pipeline B can fill the same reservoir in 5 hours. And pipeline C drains. Drains the reservoir in 3 hours. If the reservoir is empty and all 3 pipelines are operating, how full will the reservoir be after 1 hour and after 2 hours? Under the same conditions, how long will the reservoir, after how long will the reservoir be filled? Okay, so boy, we've got kind of the granddaddy of them all here. Distance equals rate times time, distance equals rate times time, distance equals rate times time, and to mix things up, distance equals rate times time. So this is pump A, B, C, and together.
I put my slip on.
I apparently am going to pause the video to put slippers on. All right, if you hear a crying baby, that last one didn't go so well. It fills the reservoir in 2 hours. So I'm going to say 1 reservoir equals the rate of A times 2. 1 reservoir equals the rate of B. Was the slower one times 5, I believe. Is that correct? Yes. -1 reservoir equals the rate of C times 3 hours. And here is just my generic equation, which I'm going to leave as is. The rate of A is 1/2. The rate of B is 1/5. And the rate of C is -1/3. When they are working together, we have distance equals rate of A plus rate of B plus rate of C. That's distance equals 1/2 plus 1/5 minus 1/3. Okay. The common denominator between 2, 5, and 3, they're all relatively prime. So I'm just going to have to multiply them all together is 30. So distance equals, that would be 15/30 plus 6/30 and minus 10/30. And times time. I forgot to do that in my other iterations. Times time. Okay. So distance equals, looks like we've got 11/30 when I add them all together. 11/30 times time. Okay, let's answer these questions now. If the reservoir is empty and all 3 pipelines are operating, how full will the reservoir be after 1 hour? Part A, if I plug in a 1, 11/30 full. After 2 hours, it's nice and linear, it will be 22/30 full. Called that B, although I guess that was the second part of A. Under the same condition, after how long will the reservoir be filled? So this is A part 2, I guess. And in B, I'm going to say 1 equals 11/30 of T. T apparently equals 30/11, a little less than 3 hours. What do we got? 2 and 8/11. T equals 2 and 8/11 of an hour. Okay. Thank you for playing along, and I will catch up with you next week. In case you missed it, the test, we are scooting back a day, and that ends up scooting it all the way back to Friday, seeing as we were testing on Tuesday, and Wednesday is a flex day, and Thursday we X. So test on Friday.